And finally, we come to the last specification of this unit, specification number 5, which asks us to explain accommodation to view near and distant objects in terms of the contraction and relaxation of the ciliary muscles, tension in the suspensory ligaments, shape of the lens and refraction of light, with respect to near and distant vision. Accommodation is the eye's way of adjusting the lens shape to focus on objects at different distances. For near vision, the ciliary muscles contract, suspensory ligaments relax, and the lens becomes thicker and rounder, focusing light from close objects onto the retina. For distant vision, the ciliary muscles relax, suspensory ligaments tighten, and the lens flattens, allowing light from far objects to focus properly. In short, accommodation changes the lens shape through muscle and ligament adjustments to ensure clear vision at all distances. In terms of vision, accommodation is the process by which the eye adjusts to focus on near and distant objects. This is achieved by changing the shape of the lens so that images are sharply focused on the retina. The lens is elastic, and its shape varies depending on the tension in the suspensory ligaments attached to it. These adjustments are controlled by the contraction or relaxation of the ciliary muscles. For near vision, the ciliary muscles contract, pulling the border of the choroid closer to the lens. The suspensory ligaments relax, allowing the lens to become thicker and rounder, which increases its refractive power to focus on nearby objects. For distant vision, the ciliary muscles relax, and the border of the choroid moves away from the lens. The suspensory ligaments tighten, pulling the lens into a flatter shape. This reduces its refractive power, allowing the eye to focus on faraway objects clearly. Thus, accommodation ensures that the lens changes shape appropriately, enabling clear vision for both near and distant objects. When we talk about accommodation for focusing on near objects, the eye makes specific adjustments to see clearly. When an object is close, the ciliary muscles contract, which reduces the diameter of the circular muscle ring around the lens. This contraction loosens the suspensory ligaments, decreasing the tension on the lens. Because the lens is elastic, it becomes thicker and more curved. This rounder shape increases its ability to bend or refract light, so light from the nearby object is focused sharply on the retina. A simple example is when you hold your hand very close to your eyes to look at it, your eyes may feel slightly strained or tired because the ciliary muscles are working hard to maintain this focus. As you can see here, a diagram illustrating accommodation for near vision. When focusing on a close object, the ciliary muscles contract, pulling the border of the choroid closer to the lens. This relaxation of the suspensory ligaments reduces the tension on the lens, allowing it to become thicker and more rounded. As a result, the lens can bend light more strongly to focus it sharply on the retina. In the front view of the eye, you can observe the rounder lens, the ciliary muscles, the choroid, the retina, and the suspensory ligaments working together to achieve near vision. This demonstrates how the eye adjusts its lens shape to focus on nearby objects. Now let's look at accommodation for focusing on distant objects. When the eye focuses on something far away, the ciliary muscles relax, which increases the diameter of the circular muscle ring. This relaxation causes the suspensory ligaments to tighten, pulling the lens into a thinner and flatter shape. A thinner lens bends light less strongly, allowing the nearly parallel rays from a distant object to focus precisely on the retina. This process feels effortless compared to near vision because the ciliary muscles are relaxed. It shows how the eye adjusts the lens shape to see distant objects clearly without straining. Here you can see a diagram showing how the eye accommodates to focus on distant objects. In distance vision, the ciliary muscles relax, which causes the border of the choroid to move away from the lens. As a result, the suspensory ligaments are pulled tight, creating tension that flattens the lens. A thinner, flatter lens refracts light less strongly, allowing light rays from distant objects to focus precisely on the retina. This adjustment ensures clear vision of faraway objects without straining the eye. The labeled diagram highlights the flatter lens, relaxed ciliary muscles, suspensory ligaments, choroid, and retina, making it easier to visualize the changes involved in distance vision. Finally, we can understand accommodation more clearly with the help of this table. It summarizes how the eye adjusts for near and distant objects. The ciliary muscles contract when focusing on near objects, reducing the diameter of the muscle ring, while they relax for distant vision, increasing the diameter. The suspensory ligaments slacken during near vision, reducing tension on the lens, and tighten for distant vision, increasing tension. The lens shape changes accordingly, it becomes fatter and more curved for near objects, allowing stronger refraction, and thinner and flatter for distant objects, allowing weaker refraction. This ensures that light refraction is optimized. Light is strongly bent for near vision to focus the image on the retina, and less bent for distant vision to achieve the same sharp focus. This table provides a simple way to see how the ciliary muscles, suspensory ligaments, lens shape, and light refraction work together to maintain clear vision at different distances. That concludes Unit 14.2, where we looked into the important features of the mammalian sense organs. I hope you found it useful. Make sure to stay tuned for the upcoming lectures, and do check out the notes linked below.